So right now we want to find this. And this actually is a CDF. I think you remember the definition of a CDF. It should be a random variable lower than or equal to a specified value t. And so how to have this is 1 minus this probability t 1 greater than t. And so that we have this result. If we have this result, and previously we didn't have the relationship, PDF actually equal to the derivative of a CDF. And so that we have this. And actually this, what is the distribution? The distribution follows the definition if you can look up the definition of exponential. So we have an exponential. Alright, so the conclusion is this one. Therefore, if we have a reference time interval to have the next inter-arrival, so the inter-arrival time follow exponential distribution. Perhaps you have a question why this is an exponential equation. After looking up, yes, we define this one to be the PDF of an exponential distribution. So of course, it should be exponentially distributed. Well, this is the result of Poisson process for the first inter-arrival time. So we can continue. Well, previously we choose a reference point T0, and right now we can choose next arrival to serving as T1, T1 serving as a reference point. So we can have the second one, third one to the other one, all follows exponential. Alright, so you see, all follows exponential. And also for all of these, they are independent, but this one is hard to explain. Alright, and this, before this, actually it's easy to have the way to explain, follows the exponential distribution. And finally, we let you know, okay, inter-arrival time T1, T2, T3 to the others, they are independent of each other. This one, I think currently it's hard to prove it, but at least it's true. We have the property. As for how to explain, in fact, in the past, I never checked how to prove it, but maybe someone provide the proof about T1, T2, T3, and the others are independent of each other. So for this one, I think hard to explain. So they may keep it, but we have the description for Poisson arrival process. We have the exponential inter-arrival times. Well, this is a way to explain. Because of exponential, so that memory property actually for exponential. And what it means, memory property. Later I can let it have this. For example, oh, okay. We have a time variable greater than a plus b, given t greater than a. Then, okay, something like longer than a plus b, but right now you know, oh, okay, greater than a, so simply we have t greater than b simply. And if we can follow the property, then it's exponential. You can use the distribution t here. Actually, this one follow the current given property, memory property. For this, I think I skip it. You can look up, or maybe right now you can use Google memory property and exponential. Then we will have some definition for you. Actually, the definition, this one. This is a way, the only one is a continuous one to have the memory property. It's exponential. And another one in the discrete time domain should be geometric. Alright, so talking about the distribution, only two distributions follow the memory property, exponential and geometric. And I think you can use Google to look at these. And because of exponential, so we have the memory property, but the memory property not full. Poisson. Only for Poisson's inter-arrival time. Poisson's inter-arrival time exponential follows the memory property. So actually, somewhat I have a correction for the current discussion. Memory property for Poisson? No, it should be memory property for exponential. However, for the following, we have some property. In fact, we have the property here. I use a new page. And later we will get back to this. We have a Poisson. And so that Poisson arrival, we have a rate lambda. And assume we have a probability P1 to Pn, and the summation of Pi from 1 to n equal to 1. So if we have the given probability, and what is the process? The process still Poisson. And the rate changes to lambda multiply the corresponding probability P1. So maybe we have I, so it should be lambda multiply Pi. So this is the splitting property. So this one actually not discussed in the current classroom, but actually it's possible. And actually, why is still Poisson? In fact, it can be derived. So how to derive it, I think you can think about that, but currently I don't derive it for you. I just mentioned we have the splitting property. Let me mention this again. In fact, it can be derived. Even you can check GD why Poisson can have the splitting property, as it can show you the reason, right? You can try that one. And so that ChatGPT serving as the TA of the course. Alright? So you can try to do that. Splitting property. And next one, merging property. Is it okay to have a Poisson rate 1, rate 2 to rate n? All are Poisson, of course, they are independent. And so that we can have the merge one. Merge one actually is Poisson again. And what is the rate? Rate equal to sum. That's it. And also this one, actually you can prove it as well. It's still Poisson. And follow this merging property. And merging property says if we have n independent Poisson process and they have the individual rate, lambda I. And finally, if we can merge them, so what is the process? The resultant process is still a Poisson process with a rate equal to sum of all the previous rates. So this is the merging property, and actually merging property here. Is it okay? Likewise, if I want to see the ChatGPT to serve as a tutor, I think it can provide you the possible proof, right? So something like, even I don't finish all the proof for the two property, you can try to ask ChatGPT to provide you how to prove merging property and splitting property of a Poisson process. All right, maybe let me start here. So that you have 2 minutes to check it. I asked Guru 1 using ChatGPT to look at splitting property and Poisson and you find the solution. And good thing, merging property of a Poisson, how to prove it. And 2 minutes later, for the others, feel free to look at the property. I asked 2 groups, group 1 and group 3, to find the possible solution. Yes or no? Even I don't check it, but I think maybe we can have some procedure to prove. 2 minutes to have for the answer. So, yes, on blue one, you can find sleeping property on actually the internet, right? Talking about sleeping property, perhaps maybe not the complete proof, but you can refer to that one. How you can find the possible proof for sleeping property and the about merging property? Yes or no? Yes. Oh, yes. And it seems to be yes, so I think you can follow the suggestion if you want to know more. And in the past, I only use Google. ChatGPT actually tries to have the final decision for you, right? Or maybe Gemini tries to find, okay, you can try Gemini as well. All right. Gemini says it should be the best one currently if we follow some performance matches. Gemini, Google's AI agent, right? So we have Gemini, 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 right? So you can use Gemini to check that one. So that says I don't provide any proof, but I mentioned yes, we can prove it. Even okay, those results they are not the rigorous proofs. You want to have the rigorous proof for the individual one, you can try to pass on those knowledge to have the rigorous proof. I guess also you can try. Why I ensure this one? Because in the past I have proved them. So I know they can prove. Alright, so they can be proved.